it's great to be here. And when Gus said, hey, I've got a problem, I need a speaker, can you do it? And I thought about the group, and I thought about a couple of things that are very, very important to me, is you're multi-centered disciplined. You come from a lot of centers, and some of you come from DOD and the Air Force organizations, and so all of these kinds of things I'd like to talk about this morning apply very, very importantly, I think. So it gives me an opportunity to say that. Now, saying it is not good enough, as I've discovered, so we have to have a test. So I want everybody to take out one of those nice pads of paper right here and write their names on top, because we're going to have a quiz. All right? All right, we're going to have a quiz. This is a forum. This is a learning exercise. This is an exchange of information. Now, normally I would say anybody that has a question as I go along, speak out, but because I've only got 45 minutes and then I want to save 10 minutes afterwards for this 50-page presentation, this is really cutting it, I'll save the questions till the end unless you just don't understand an adjective or an expletive that I'm using. Yeah, okay. All right, you got the message. Okay, so I want to talk about the spirit of Hubble. I want to talk about really the technology leap that's responsible for all the Hubble discoveries, and you'll see a chart on what those discoveries are as we go through the thing. But I want to talk about the story behind the story. And the story behind the story doesn't start now, and it didn't start in 1986 or something when the program officially got started, or was it 76, in 76 time frame. No, the story started almost at the beginning of NASA. And that's the thing, the history part of it. And I want you to, 4 subtle parameters that you're going to get out of this discussion for you program managers and satellite managers and hardware managers especially, and cost accountants. How many here are cost accountants? How many here do anything involved with budgets? Okay. All right, I want you to remember 4 words or 4 phrases. Architecture, rapid, fresh technology to orbit, planning for the future, always, and the last one is collaboration. The thing we do the poorest of at NASA is collaboration, and I'll talk to that at the end. Okay, so those are the 4 key subtle messages I want to leave you from the point of view of cost containment, cost control, satellite development, program development. Is your architecture is your number one driver in cost control. Okay, so we'll start with Hubble. Now, way back in the late 60s, NASA was launching between 1960 and 1968, they had launched something in the order of 240 satellites. Of those 240 satellites, about 60% of them failed to last more than a year. About 38% failed to operate more than 30 days after they got to orbit. Now remember, this was in the beginning of the space program. So a big effort was initiated by the Deputy Associate Administrator to find another way to expand the life of satellites and get more scientific return for investment, and to take advantage of potentially new systems like a to-be-developed, at that time to-be-developed shuttle, and how 2 systems could work together, unmanned satellites to do scientific work and Earth exploration work, working with a manned system called a space shuttle, which had 2-way capability. So really going back in time, 1970, 71, we started putting together the concept for modular serviceable spacecraft systems. And we worked with Johnson and we worked with Marshall. We even used Marshall's tanks, water tank, to do a bunch of feasibility work. And we developed a concept of modularity, an architectural concept of modularity, which really equated from a Goddard perspective, and I'm from Goddard Space Flight Center, so there's a built-in bias here, that if in fact you chose your configurations properly and your equipment properly so that it represented minimum interfaces going across subsystems, you could have a better chance of improving the reliability of your system and containing the cost of those individual modules and those individual systems. And we're going to talk a little bit about that as we go along. So that's the thing that I wanted to leave with you, is that even back in the early 70s, 71, 72, 73 timeframe, the question of how to reduce cost, improve reliability, factored down into this concept called architecture. Now, we built quite a few different satellites and flew them before the Hubble launch. The first servicing mission took place in 1984, and that's with a spacecraft called Solar Max. Solar Max was designed to be fully serviceable and modular. But we did not spend any money to man-rate it. About the only thing we did was make sure that on the outside of those individual modules, there was nothing on board. I'll back up one. There was nothing on this satellite. There was nothing on the satellite that was sharp-edged. Everything was smooth, and we had the astronauts walk down the satellite before we launched it on a Delta launch vehicle to make sure that everything was comfortable. There were no EVA handrails. There were no particular emphasis on man rating or anything of that nature. The specifications only covered the ability to launch this thing from an environmental perspective, both on shuttle and on a Delta. It was launched on a Delta, and it was serviced on the shuttle. Interesting point, because 6 months later came a mission called Westar and Palapa. Those two satellites were retrieved. You know how much money they spent on those satellites to man-rate them to bring them home safely? Zero. The same analogy with Solar Max, the same analogy with GROW, and GROW was serviced before it ever left the cargo bay because it couldn't deploy an antenna. $0 for man rating. So this argument that you get about spacecrafts being too expensive to be serviceable is, okay? It's absolute propaganda. And if you don't believe me, ask SINCOM 4, ask Intelsat 6, GROW, TOPEX, the rest of them. They're all serviceable, they're all reachable, but not a penny was spent to man-rate them. So it's kind of a fallacy that you walk into here when you talk about cost implications associated with making your systems so they can be serviced on orbit. And as a matter of fact, what's now happening in the DoD world is they're doing it robotically. Orbital Express is the best example of that 6 or 7 months ago. The one thing about modularity that it brings to the table is that big missions like upper atmospheric research satellite, which weighs something in the order of 20,000 pounds, gamma ray, which 25,000 to 30,000 pounds, those modular systems came together and integrated themselves into instrument platforms in less than 6 months. 1/3 of your program cost, 1/3 of your program cost resides in integration and test. If you can bring in fully tested, flight-tested subsystem modules and pluck them together, mechanically integrate them with single or dual connectors for each module, you can drastically reduce your integration and test time and thereby drastically reduce your cost. We witnessed those very things with Landsat 4, Landsat 5, or Solar Max, TOPEX, and the rest 16 other modular systems that were built in that period of time. So again, architecture is your major, proper architecture is your major